Hi everyone, my name is Omar and I'm going to present my work about reducing before you repair, advantage of combining program slicing with automated program repair. And first I will describe why we need to combine automated program repair with program reduction techniques, or why we need to accelerate the repair process of programs. Then I will describe the key contribution of this work. I gave a demonstrating example where the acceleration is required. Then I summarize a number of key research questions that we studied and some of the results that we obtained, and then I concluded the presentation. Um, Current APR tools simply take too long, particularly when we try to repair a large-scale program. We find that the repair time is too long. And when we investigate, we find that the key reason of the slow running time for the APR tool is mainly due to the large number of patches that the tool examines or analyzes before finding a valid or a good patch. So we would like to reduce the repair time by eliminating irrelevant patches or infeasible patches. So that to do so, we combine what we call observation-based slicing, which is a recently introduced slicing technique, dynamic analysis technique, with an automated program repair. And the goal of this process to eliminate part of the code that irrelevant to the bug being repaired. And as a result, we identify and eliminate irrelevant tests and improve the suspicious list or the list of suspicious statements that are generated by the fault localization tools when we apply them to the faulty program or to the buggy program. As a demonstrating example, we were working on the dataset defect for Java, and we were analyzing the example, one of the bugs in the Lang project called Lang 10. And we find that when we apply template-based repair tools like TPAR, it takes 7 hours or even more to fix the bug Lang 10. And when we analyze that bug, we find that there is a large number of passing tests associated with this bug that is irrelevant to that bug and can be easily eliminated without affecting the repair process. And we find that the rank of the actual faulty statement that is responsible for this bug is too low in the suspicious list. And again, because we apply that tool directly on the original large program, so we can reduce the program and then we apply the APR tool. That's the goal of the paper or the slicing technique. So as for the key setup that we use in this paper, we use GZORITA to identify faulty statements. We combine it with the ORPS slicer, the dynamic analysis technique that we combine it with the TPAR tool. And as I mentioned, the goal is to eliminate irrelevant tests and to improve the ranking of suspicious statement by identifying false positive statement and eliminating them from the list. We choose TPAR because TPAR is a template-based automated program repair tool that shows effectiveness, but it has an efficiency issue. So it takes or performance issue. It takes too much time to find the patch when we apply them directly on a large size program before reducing that program by eliminating irrelevant code. In this work, we analyze a number of research questions. In this presentation, I just selected 3 of them. The first one, how effective is ORPS in reducing test suite, and how effective it is in improving fault localization result, and how effective also the tool in improving the performance of the repair tool TPA. Regarding the first question, we find that the slicing technique or the slicer that we employed here was very effective in the sense it can identify and eliminate irrelevant tests to the bug being repaired without affecting the quality of the generated patch. So it just eliminated tests and still produced the same patch that we produced for the original program before applying the slicing. And we find also that the slicer also improve the ranking of the faulty statement, and by eliminating false positive statements in the list. So now the ranking becomes better. We can find the patch faster. And because the size of the test suite becomes also smaller by eliminating irrelevant tests, we reduce repair time, and we can find the patch much faster when we combine TPAR with the ORPS slice. About the performance, we found that TPAR performance has been significantly improved for most of the cases that we analyzed for the reasons that I mentioned, because the defect for Java often exhaustively like verify the correctness of the patch by including irrelevant test and irrelevant code. So when we eliminate these, we find that TPAR is performing much faster and much better. So in conclusion, we combine a dynamic slicer technique, which is recently developed called ORPC, with the APR tools, and we show effectiveness in improving the performance and the efficiency of these tools. So in conclusion, instead of examining the entire program, we can apply slicing to eliminate irrelevant code and to focus only on small portion of the code that contain the bug and the suspicious statements that directly cause the program to fail. This helped to improve the efficiency of the repair process, and to reduce the repair time. Thank you. This concludes my presentation.